Hey everyone, my name is Vikram and I welcome you all to my channel Learn and Reflect. Today we are kicking off our brand new series dedicated to sorting algorithms. Over the next few weeks, we will systematically break down all 12 major sorting algorithms, exploring each one in its own dedicated video. This series is built right on top of our comprehensive GitHub README file. Think of it as your ultimate textbook for these algorithms. I am sharing the link of this repo in the description for this video. Today, we are starting with the simplest algorithm, bubble sort. So what is a bubble sort? It is the one that compares adjacent elements and swap if they are in the wrong order. Remember the name bubble sort. What does it do? It bubbles up. The largest elements bubble up to the end. Let's go through a code sample to understand this. For bubble sort, it requires two for loops. The first one is the outer loop, where it controls the number of passes through the array. We need at most n minus 1 passes to sort n elements. While the inner loop, where the magic happens, it compares the adjacent elements like what you can see here, and if required, it will do the swap for them. After each pass, the largest element bubbles up to the end. So we can reduce the range by I. Why? Because the last I elements are already sorted. That is the reason inner loop goes from 0 to n minus I minus 1. Now we have also done an optimization here where if there are no swaps which are done in the inner loop, then we can break early from the outer loop because the array is now already sorted. Now let's go through a step-by-step example by taking the array 5, 1, 4, 2, 8. Now in this case, let's find the largest element, which is 8 in this case. So in the first pass, it will find its right position. It will get bubbled up towards the end, where it is already at the end to start with, but now 8 is secured position and 8 is sorted. The same way, it will find the next largest element 5, and now 5 and 8 are bubbled up towards the end and both are sorted. So it will continue to do so one by one until there are no further swaps possible, in which case it means the array is already sorted. Now let's look into the complexity analysis. In this case, for time complexity, it is O of n square. Well, why? Because we have these two for loops. That is the reason the average and worst case time complexity is O of n square. The best case, in which case the array is already sorted, it is O of n. Space complexity is O of 1 because it is in place sorting algorithm. With respect to stability, yes, it is stable because it maintains the relative order of equal elements. Now, when to use this? You cannot use this for large scale production purpose, but it is still a good algorithm to learn from a teaching standpoint to understand the fundamentals of sorting. Now, apart from this, we also have compiled a complete algorithm comparison table towards the end of our README file. Today, we looked at bubble sort, but you can compare this bubble sort against all the other algorithms when it comes to the complexity, the stability, space, the best use case scenarios, etc. Now, let's make sure that you are subscribed to Learn and Reflect so you don't miss out our deep dives into the rest of these algorithms. We will explore when to use each one, interview insights, and more. Thank you for watching, and I'll see you in the next video.